Okay, welcome. We will now do a second instruction. I know I gave them to you in a different order, but I'm going to do the sub instruction next. So the sub instruction looked like this. It was sub, hopefully I'm getting a little faster in my writing, okay? And then it was, let's see, $T1. Oh, I'm getting too fast. All right, $T1. That's a 1. Sorry about that, folks. Okay. $S0. And again, these dollar signs, that's just the common notation you need when you're programming in MIPS for the different registers. And that's a comma. $T3. Okay. So if you watch the previous instruction on how to do the add, sub is going to be very much like that. Sub is an R format instruction. I know that by looking in the alphabetical list side of the green sheet and seeing that sub, when I find it alphabetically, is an R format instruction. So I'm going for an R format instruction. I've got a place for the opcode. Okay. I know I need a place for the RS, the RT, the RD. I have a place for the shift amount, 5 bits, but not going to use it. I'll make it zeros in a minute. And then this is for my function code. And once again, when I go on the green card to find the opcode for sub, what I find is that he's part of group parentheses 1. And what that tells me is his opcode is all zeros and he needs a function code. Okay? And when I go to look for his function code, it turns out that it is 22 in base 16, or hex. So we'll figure out what that is in a minute. Once again, I also have to remember that the way this is written, this is the RD. Forget, the way it's written out when you program in MIPS, the RD comes first, because that's a little closer to what C++ and Java look like. This is your RS, and this is your RT. All right, so we're going to have to do some rearranging down here. So down here, my RS should be, I'm not going to do dollar signs because you know how my writing looks. S0. RT means he's going to be T3. And RD means he's going to be T1. Shift amount, we don't use that here in subtraction, so that's going to be a 0. Remember, this is 6 bits. RS gives me 5 bits of space. RT is going to take 5 bits. RD, 5 bits. Shift amount, 5 bits, all zeros. Function, 6 bits. All right, let's start breaking this down, get some numbers here. I think I got some dark blue, we'll see. So the opcode, as I said before, for group parentheses 1, it's simply 6 zeros. Some of them are bigger than others. Okay. S0, I can look that up on my sheet and find out that S0 is register 16. That's in base 10. Okay, so I'll figure out that number in a minute. T3 turns out to be register 11 in base 10, so be careful there, it's a base 10 number. T1 turns out to be 9. Shift amount, all zeros, and I'll put them in now, that's going to be 5 of them. Shift amount always takes 5 spaces, or 5 bits, and it's 0 for us for that, for every time you use subtract. And then the function code of 22 in hex, let's turn that into 6 binary bits then. 2 looks like this, okay, a 1, 0. And now I've got 4 bits to write this next to. So 4 bits means I start with a 0, 0, 1, 0. That's a 2, and that's a 2, 22 in hex. Right? So I've already got my function code, my shift amount, and my opcode into binary. Let's get this number 16 into binary. I've got 5 bits to do it in. And good thing, because I'm going to need them. 11 in binary, remember that's an 11, happens to look like this. And as I've told you before, if you're a little slow on turning numbers from binary to decimal, decimal to binary, you'll want to go check out some useful links for that. And a 9 looks like this. Okay. Oh, no, it doesn't. It looks like that. Okay, 0, 1, 0, 0, 1. Okay. Let's see, let's bring down our shift amount and our function code, as I'm about to chop this into 4-bit chunks. Don't miscount. Make sure you get all 5 for that and all 6 for this one. Coming back up here, let's go ahead and fill in our opcode. I'm going to fill it in from right to left because it's all zeros anyway, so that's pretty easy to do. And there you have it. That should be 32 bits of an instruction. Now, what I want to do, as I've shown you before, is let's divide this now into 4-bit chunks. And I'm going to make dividing lines. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's another 4. Another 4. Now, if you get to the end and you don't have 4 left, first of all, see if you divided it up properly. Second of all, see if maybe you didn't transcribe some of your bits down. You got one of the counts off. Okay? Back up here, I'll turn it into hex. That's normally what I want to see in a homework or a quiz. There's a 0. 0, 0, 1, 0 happens to be a 2. Okay. All zeros again. This guy here happens to be what? That's 1 plus 2 plus 8. That's an 11. Okay? 11 in hex happens to be a B. 10 in hex is an A. 11 is a B. Okay? This guy here is a what? A 4? Yep. No, yes, he is. This guy here is an 8. I'm just going to check this out. Here's a 2, and here's another 2. This is my instruction in hex. Here's the same instruction in binary. Here's some more. Here's the instruction in the MIPS programming language that you'll use in your programming assignments.